Do those two. Number 4 is just getting this back into y equals mx plus b, getting y by itself. So we would get rid of the 3x by subtracting it to the other side. And that would leave us with 5y equals negative 3x plus 15. And we could divide everything by 5. We have y equals negative 3/5 x plus 3. Please follow me. Questions on that one? Number 5 is already in y equals mx plus b format. So you graph it like a normal problem starting at 2. Your slope is a negative 3 over 2, so we can go down 3 to the right 2 as many times as possible. If we kept going, this one would go off a little bit. And then the type of line is dependent on the symbol. So this is a strictly less than, so this would be a dashed line or dotted. And because it's less than, it would be below. So at the y-intercept, below would be underneath, so everything here. And you would shade it. Remember, shading is the most important part because that shows you where all your solutions are. That makes it the inequality. Other questions on that one or other questions on the shortcut in general? Look at your course calendar. The days are off by a day because of the snow day yesterday. So if you want to go ahead and change them all, you can do that. I'm not going to give you a new one. So everything would just be pushed a day, starting with Wednesday the 7th. I think we're going to keep the delta mass the same because we'll still be able to do both of those this week, today and Friday. So you will have delta mass due on Friday, one after today's lesson, one on Friday's lesson, and then so on and so forth. Keep in mind that Unit 5, what we just finished, and this unit is all on Marking Period 3. Marking Period 2 is done unless you need to finish, not finish tests, retake tests from Unit 2B, Unit 3, or Unit 4. Questions on any of this? This unit, if you don't remember this from Algebra 1, you've got to be paying attention. Because factoring is a lot of you pulling pieces of information from kind of all over. So you got to pay attention. If you weren't doing so last quarter, try to do better. This quarter, write down more, take more notes, come get help more, all of those things. Lunch should be at 36, but I'm not 100% on that, so we'll see how that is. So everyone should have notes that look like this. We're going to start with this warm-up piece to kind of get you back in the mindset of how some of this even works. Okay. So these, we need to simplify these polynomials. If this were a normal number out here, what would I do with it? Distribute. So same thing. I'm going to distribute whatever's outside to whatever's inside, but when you distribute the variables, a times a, you're going to make that a squared. You're like taking them and adding the exponents. So this would become 3a squared plus 7a. So however many there are, add another one as the exponent to it.
So the second one will be m cubed.
M cubed, yeah. So when we distribute this one, distribute it to everything, that would be negative 2m cubed. What would the middle term be?
Plus 6 squared.
So it would be m squared, and then also multiply the numbers, so negative 12m squared. And then the last one would just be a normal m, but with a positive 2. The last one's a little bit more complex because there's multiple variables, so take it step at a time. We're still taking this entire thing and distributing it to both terms. So let's start number-wise. This would be 4 times 1, so still just 4. We have x's. What would that new exponent be? We had 3 and 2, and I'm combining them together. 5. So 4x to the 5th. There were no other y's, so the y that was there originally will just come behind it. And then when we do it to the second one, we can multiply 4 and negative 2. There are no x's, so this x would stay the same, x to the 3rd. What would the y's become?
Squared.
Squared. Right, so those are all good things to keep in mind, because this is going to be a good way to check yourself when we get into what we're doing. Questions so far? I don't remember this exact definition, so I'm going to break this down. And I'm going to have you write this one. So, when we talk about factoring, you may remember some of this. We are separating a polynomial back into a product. So what it would look like before we multiply. Basically, this, we're going to be given this, but we want to find this. We're going to be going backwards from what we just did. So go ahead and write this, the simplest form and the factor form, and I'm going to show you how we would get from one to the other. Someone's music over here is too loud. All the music is too loud. Alright. So with this, factoring is like dividing. I'm going to rewrite it for a squared plus 8a. If you didn't get the second part, that's okay. It's like dividing. You're looking for, what do these have in common? What could I divide out of both of these? So numbers-wise, let's say, we could probably see that right off the back, but just in case you couldn't, let's list out off to the side the factors of 4. Okay. So what times what will give me 4?
2.
2 times 2, and always one that everyone forgets.
4 times 1.
4 times 1. 1 times 4 does not. Let's do the same thing for 8. What times what would give us 8?
4 times 4.
4 times 2. And 8 times 1. Always use the 1 times itself. Now, looking at these two, what number do they have in common? What is the highest number they have in common? 4. So that would be our, what is called a GCF, greatest common factor. We'll talk more about that in a second. So we would divide both of these by 4. But when we divide, we are dividing, but not at the same time. It's a little weird. So whatever we are dividing by goes outside. Before I talk about what's inside, we have to deal with the A's. So then you also look and see, do both of your terms have the same variable? In this case, yes. And what is the smallest amount that they both share? So do both of them have 2? No. But both of them could have at least 1. So the smallest amount of A's they both share is 1A. So I would be dividing both pieces by 4A. So that's what's going to go on the outside. And then when I divide, whatever would be left is going to go on the inside. So 4a squared divided by 4a, what would be left there? Not the 4, so those will cancel. Okay. Just 1a. And then nothing else. So I can put the plus from the original. And then if I divide 8a by 4a, what's left? Just 2. The a's would cancel. This is 2. So we took the GCF, the greatest common factor, of the two terms, divided it out of all of the terms to see what would be left. On the inside, you know you're done when you can't pull anything else out. You can't divide anything else out. Those are considered to be prime. So you think about prime numbers, the factors are only itself in one. Prime factors, you can't divide anything else out except for one. Similar, but different. Questions on that so far? Okay. So then go ahead and read through the steps for how to find a GCF, and then we're going to start this process. So we did steps 1 through 2 when we did that one. We did not do step 3, so I'll do that really fast so you see that it works. So if I wanted to double check, did I do this correctly? I could redistribute, just like we were doing before, to see, do I get the original? If I do, I did it right. If I don't, something's off. So if I were to distribute this, I should get 4a squared plus 8a, which is the original. So you could always do that no matter what. Right. Looking at number 1, sometimes you can see it without writing down the factors, but it is good to still write out the factors for practice. What are the factors of 3? 1 and 3. What are the factors of 12?
6 and 2.
6 and 2 is one of them.
4 and 3.
4 and 3 is another.
12 and 1.
12 and 1. That's it. What is the highest number they both share? 3. Now sometimes the smallest number here is that GCF, but sometimes it's not. So writing out the factors is good help. These both do not have an x, so there's not going to be an x in the GCF. I'm going to divide both of these by 3. That number is going to go outside of parentheses. If I divided both by 3, what's left? X plus 4. If I were to distribute this back, I would get 3x plus 12, which is what our original was. So that works. Questions so far? And number 2, the numbers are the same, and it's a prime number. So our GCF in this one would be
7.
7. So I can divide these both by 7. That would be outside. If I divide them both by 7, what's left on the inside?
Y minus 1.
Y minus 1. 3 is a little different because 8 does not go into 36. So 8 could not be the GCF. So let's list out our factors. 8 from before we know are 1 and 8 and 2 and 4. What are some factors of 36?
4 and 9.
4 and 9. If you're not
6 and 6.
sure, 6 and 6. If you're not sure, you could start dividing. 36 divided by 1, by 2, by 3, keep going until the numbers get close enough together. Or they're exactly the same. So I know if I started dividing until I got to 6, 6 would be my endpoint. That would be done. So what are some other ones?
36 and 1.
36 and 1. and so it's divisible by 2. 2 and
18.
18. And if you add up these digits, and you can get something where you could divide by 3, so 3 plus 6 is 9. 9 divided by 3 is divisible, so that means 3 is also a factor. 3 and 12. Now sometimes you don't need to list out all of them, but it just helps so that you start knowing these. What's the highest number of these share?
4.
4. Do we have similar or the same coefficient of variable? No. So no variables, just 4. We divide them both by 4. What's left?
M plus 9n.
So close. The 9n is correct. It will be m, but what number? 2m. So sometimes you will have numbers for both and variables for both if they're not the same. Right, we'll stop at that one and come back and do 4 when we do that. Looking at number 4, could you guess what number we could divide both of these by just by looking at it? 5. Now, if you wanted to do this, you could, but 5 is a prime number. So 5 would definitely be part of the GCF. Could we divide out any variables? Do they have the same variable? So, just 5. What would that be when we divide it out? What would be left? 6. Y for the second part.
X plus 6.
X plus 6y. Do you have any questions so far? We're not going to do every single problem on this, but I do want to show you some specific ones. So let's start with number 6. For number 6, can we think of a number that we can divide both of those by? 4 would work. Do they have the same variable?
Yes.
Yes. So how many y's do they have in common? Just 1. They don't have 2 in common because 1 doesn't have a square. So I can divide both of these by 4y. That would be my GCF on the outside. If I divide both terms by 4y, what's left? Think about the first one like you had 2 y's and you took 1 away.
So it's y
Y.
minus 6.
6. That's it. Finding what they have in common is probably the hardest part of this factoring. Let's do 8. I'm going to list out the factors of 14 and of 18 off to the side. What times what would give us 14?
7 times 2.
7 and 2. And
7 and 1.
1 and 14.
Okay.
I like to put this in order. You don't have to do that. Just for me, it helps know I went down the list and that's everything that's going to be. That's it. And then for 18, what are our factors there?
6 and 3.
6 and 3 work.
9 and 2.
9 and 2 work.
18 and 1.
1. And then if you tried anything between 3 and 6, 4 wouldn't work, 5 wouldn't work, and then we already did 3 and 6, so we know that's it. What's the highest number between these?
2.
2. So sometimes the number is not very high at all. So that would be our number GCF. Do we have anything else in common? H. So we could divide both of these by 2, 8. And then what would be left?
7G.
7G. minus.
Minus 9.
Now we're going to take it up a notch with multiple variables and exponents. Let's do 9. So again, I'm going to list out the factors off to the side. You don't have to do this for every single one. Sometimes you may just know this is it. Factors of 15. What times what will give me 15?
3 and 5.
3 and 5.
15 and 1.
15 and 1. Are there any others?
No.
Wait, 30 has a bunch. What would multiply to be 30?
6 and 5.
6 and 5.
15 and 2.
15 and 2.
3 and 10.
3 and 10. Anything else?
2 and
Is that 2 and 15? Because obviously
1 and 30.
Alright, so what is the highest number that they will share?
15.
Do they have any variables in common?
A and B.
A and B. 1A and 1B, they have that in common. They don't have 2 A's because they both don't have 2 A's. So we'll divide both by 15 AB. Take it one step at a time. 15A squared B divided by 15AB. What would be left?
A.
Just one A. The B's would cancel, the 15's would cancel, just leaving A. 30AB divided by 15AB.
Minus 2.
That's it. Yeah. Any questions about that one? Okay. Now let's do some with just variables. So number 11. We don't have any number coefficients except GCS except for 1, but we wouldn't put that. What else do they have in common? For number 11? A. So I could divide these both by A. What would be left? B minus 1. So even if you divide it out or cancel them out, there's still going to be a 1 there. Questions on that one?
I know.
Guys, focus. Number 13. Do these have anything in common? 1. 5 is a prime number. 13 is also a prime number. The only factors are 13 and 1. They don't have any common variables, so this is already prime. This is already factored. Guys, so you wouldn't put anything else but prime. That's it. It's already factored, basically. Let's try 14. I already have my factors of 18 up here, so I'm not going to redo that one, but I will do 48.
I know.
What are some factors of 48?
8 and 6.
8, 6.
4 and 12.
4 and 12, yep.
48 and 1. 24 and 2.
24. What did you say?
I said the same thing.
3.
3 and 6.
I think we have everything. 1, 2, 3, 4, 5 one works, 6 and 8 and 7 one more. Alright, so comparing 48 and 18, what's the highest number there that they share?
3.
3 one number that's higher. Actually, let me show you what happens if you don't choose the highest number, and then we'll go back to that. So let's say we missed the highest number, we chose 3. For the variables, how many of each could we take out or divide out? What do they have in common? How many A's do they have in common? How many B's? How many C's?
1.
They both have 1 B.
1 B, 1 A. How many C's?
2.
So 3A, B, C squared. That's what we're going to divide that by. Divide both by. So if I were to divide it out by that, we have
This is just an example of what would happen.
6, 1A left. The B's would cancel. The C's would also cancel. Minus 16. The A's would cancel. The B's would cancel. We have 1 C left. Could I divide something else out of 6 and 16?
Oh, wait.
2, because they're both even. So if you notice that here, you didn't, or you could still divide something else out, that means you didn't divide the highest GCF out, which is okay as long as you do this, recognize this. So I can divide both of these by 2. When I divide that, I'm going to multiply it out front. So this becomes 3A minus 8C. Now I can't divide anything else out, and 6 was the highest number that they both share. So even if you don't do that first, as long as you do it eventually, you're good. Any questions on that? Okay. Now let's do some with 3 terms. Let's do 15. So this one's easy enough. The GCF of that, what number are we dividing out of each of those? 2. And then for each one, how many X's or Y's could we take out of each?
1.
1 X and 1 Y. When you get the hang of this, you can stop doing this dividing part. If it helps you, you can keep doing it. You do have to do this part though. So if we divide each piece, let's go one step at a time. 2x squared y divided by 2xy. What's that?
X squared.
One of the x's would go away.
Just X.
Just x. Next one, 2xy squared divided by 2xy. What's that?
Minus 1.
Minus y, just y. And then 4xy divided by 2xy.
Just 2.
Just 2. Plus 2. And that would be our answer. Any questions on that? Let's do 18. And then we'll do 24. And then any you guys want to see, do go for it. Alright, 18. Can we think of a number that we could divide each of these by?
6.
6 would work. So I'm not gonna write it underneath each one, I'm just gonna put it out front. How many A's and how many B's could we divide from each one?
2.
2 A's and 2 B's. If you're not sure, look at the smallest exponent. Smallest for A would be 2, the smallest for B is also 2. So A squared, B squared. Divide that from each piece. One step at a time. 12 divided by 6, A to the 5th divided by A squared, B squared divided by B squared. What would that first one be?
2 with A to the 3rd power.
The B squares would cancel. Negative 36 divided by 6, A to the 4th divided by A squared, b to the third divided by b squared, what would that be?
6 squared.
6a squared.
Yeah, 6a squared. B
And just one b. And then 6a squared b squared divided by 6a squared b squared. What would that last one be?
1.
Just 1, minus 1. Now, this looks like we should be able to do more with it because of all the exponents and variables. But if I look, these two can be divided by 2, but the last one can't. These two can be divided by a, but the last one can't. There's only one b, so nothing else can be divided by b. So nothing else can be taken out there. It is fine. Okay. Any questions on that? And basically, if you could do 24, you could do any GCF problem. I will divide each one out because there's a bunch of variables and whatnot. Can we see what number we could divide out of each of these by looking at it?
3.
3. And then how many A's, how many B's, how many C's could we take out of each one?
2 A's. No. 1 A.
1 A.
2 B's.
2 B's. B squared.
1 C.
And 1 C. Again, take it one step at a time. 3 divided by 3, a to the third divided by a, b squared divided by b squared, c divided by c. What's left in this first term?
A cubed.
A squared.
Oh.
You were close.
Squared.
And then that's it. Everything else cancels. The 3's, the b's, the c. Minus -9 divided by 3, a squared divided by a, b cubed divided by b squared, c squared divided by c. What's left with that one?
3. The B and C squared?
We would have a b squared, this is already squared. We would have a b, we would have a c, we also have an a. So a, b, c. Alright, the last one, 15 divided by 3, a divided by a, b to the fourth divided by b squared, and c to the third divided by c. What would you have?
5B squared. C cubed?
Plus squared. Because it was already cubed, and then we took 1 out. It's hard to see right there, but it does say 5b squared c squared, if you're looking on the floor. If we were to multiply that back out, which I'm not going to do, we would get the original. And if I look inside here, I can't take any A's out, I can't take any B's out, C's, or numbers. So it is factored out. Are there any others on this page that we want to see, do go over, have questions about? So, for the remainder of class, I want you to continue working on these problems. You have a bunch of practice problems in here. Try the Delta math on this that's due on Friday. If you need to do retake work, you can come see me to do that. Remember that next Wednesday is the last day to do retake work for quarter 2. And next Thursday is the last day to do retakes. So if you need to retake, today would be a great time to work on that stuff. If you need to finish the Unit 5 test, you can come see me to work on that.